In this chapter, we will talk about classes. So let's talk first about what's the difference between procedural and object-oriented programming. So procedural programming focus on the processes or action that happens in the program. So the programming what we learned so far in this course is called procedural programming because it focuses on the action and the process and how the statements are executed. But we have another type of programming, it's called object oriented programming. So, this type of programming is based on the data and the function. So, we can have something called the class. And this class is talking about some data and it has some function that operate on this data. So, it will be clear when we see some examples. And there is like a special course about object oriented programming. So, why procedural programming is not good, or what's the disadvantage? If the data structure change, you need to change a lot of things, and also it's difficult to understand and maintain. It's difficult to modify, easy to break. So procedural programming is good for small programs or middle size programs, but when we want to make large programs, you will get some disadvantages. So that's why we will move to object oriented programming. So in the object oriented programming, we have something called a class. So we in this class, we will have some variables and we will have some function that deals with these variables. And this piece of code is called a class. And from this class, we can make many objects or many instances of this class. So again, with the example, it will be clear. So the class is like a blueprint of a house. So this is the class. It's like design of a house. And from this design, you can make many houses. So this many houses is called object, and this is called class. So this is the class, and this is the object. So in the class, we have something called attributes or members of the class. These are just the variables inside the class. Also, we have something called methods or behavior. These are the functions of the class. So the class contains mainly from variables and functions. So we have something called data hiding. So the nice thing about the class, it hides the data inside it. We can make it private. And we can have something public that we can use outside the class. So let's see the example how to define a class. If you want to define a class when you write the code, you have to write class and then you choose a class name. Usually we write the class name with capital letter, unlike the variable where we start with small letter. So, and here you write the declaration of the variables and also the declaration of the function. You write declaration of the variable and also prototypes of the function, and then here you close and semicolon to mark the end of the class. This is example of a class rectangle. So we want to define a class rectangle. The rectangle is like we define a new data types in the language. Okay, so we have integer, double, but we also want to have something called rectangle. It's like a new data type. Okay. So what the rectangle consists of? Consists of width and length of type double. So it has two variables. And we want this variable to be private. So no one from outside the class can access this variable or can change their value. And we have some public functions. Here we write the prototype of the function. So we have void set width. If you want to change the width of the rectangle, you can use this function set width, set length, get width, get length, get area. So all these 5 functions are working with this data, either changing them or getting them or So this is the class. Mainly it's contained from 2 variables, 5 functions. Some function we write const. Const, we'll talk about it in the slide, but if you are not modifying the variables, you write here const. This means constant. This function is constant. Before that, we have also public and private. Public means you can use it outside the class. Private means you can only use this inside the class. Mainly the variable are private, and the function are public. Usually this is the standard to do to use the class. So we have two variables, they are private, and five function, they are public if because you want to use them from outside the class. So we can have more than one private. We can write more than one private in the class. Like you can write private here and then private here and list. But usually it's better to make the private in one side and the public in one side. So the const appearing after parentheses in the member function declaration specifies that the function will not change any data. So this will not change any variables in the class because it's get width. It's returning the width without changing the width. It's get the length, returning the length without changing the length. So that's why we write constant. How to define the functions? When defining member function, we put the prototype in the class declaration. But when we define the function outside the class, you need to write the name of the class and then double colon, and then you write the name of the function, just to show that this function is inside this class. Okay, and then you define the function like normal definition. So mutator, if the function store a value in a private variable or change the value in some way, we call it mutator because it's changing the values. Accessor is the function that only gets the value of the variables and does not change it. Mostly the accessor are the constant and mutator are the set. So if you want to set width, this is mutator, get width, this is accessor. So how to define an instance of a class? As we said, the class is like a blueprint of a house. You can make many objects of this class. So, and the class is like a prototype, a data type, sorry. So if we have a class called rectangle, this is a class, this is like a data type. So we have integer, double, and we have rectangle. I can make a variable of type rectangle r, okay? And then you can play with r. You say r.setWidth 5.2. You can also make r.getWidth, and then you will print 5.2. If you want to access some private member, you will get error, compilation error. So you only can access setWidth is a public, so you can access it. So here is the complete program. So here we define the rectangle. We have private, double width. Public, we have 5 prototypes of a function. And then here we define the function. So you see, you write rectangle, double column set width, and then this set width is just changing the width of a rectangle to W. Okay? So this is the set width. And set length is changing the length to the value that you get in this function. Get width, you just return the width. Get length, you just return the length. Get area, you just return the width multiplied by the length because the area of the rectangle is width multiplied by the length. Now in the main function, you can use that class. How to use it? You define a rectangle box and you define like two width and length, and you ask the user to enter the width and the length, and then you change this object box, you change the width with the same width that the user enter, you change the length with the same length, and then you can print the width is like this, the length is like this, the area is like, you just call get area. Okay, so in this case you write get area and you write 50. So why we have private member? Because we want to protect bad people from changing the variable of the class. For example, if the variable is not private, then maybe someone can say, let me go back to the example. He can write like box dot width, directly width, not set width, equal -5. So he can assign -5, which is not acceptable value. But inside the function, you can control that you don't want minus value. So this is kind of a protection. That's why we use a private. Sometimes you can, inside the class, you can define the function, okay? And sometimes you can define it after. So in this example, we define the function. So here we write the prototype and here we define the function. You can define the function directly here, but I think it's better to write a prototype and then define the function. So both are correct. So this is like how to define the function inside. So here inside the class, you define the function. You don't need to define it outside. So that's all. This is like entrance to this big topic, object-oriented programming. And as I mentioned, there is a complete course talking about this concept.